So in last session, we saw how to set up a Jupyter notebook with proper Conda environment and how to install packages in that Conda environment and how you can import the packages inside the Jupyter notebook. Now we will start with the project implementation. So the problem statement for this particular project is we need to predict the sleep disorder based on the given parameter. So we have n number of given parameter like person ID, gender, age, occupation and all the like biological parameter, physical activity, quality of sleep, stress level. Based on that, we need to predict sleep disorder. So in sleep disorder, there are three categories. None means the individual does not exhibit any specific sleep disorder. Then we have insomnia. The individual experience difficulty falling asleep or staying asleep. And then sleep apnea. The individual suffer from pauses in breathing during the sleep. So these are our dependent variable. Sleep disorder is dependent variable and these three are category. So this problem statement is belong to multi-class classification. Okay. Now for this particular project, we are using disorder prediction kernel. So in last session, I have explained how you can create a Conda environment and inside that Conda environment, how you can create a Jupyter kernel. And you can map that Jupyter kernel to your current Jupyter notebook. Now, you need to import the basic packages like NumPy, Pandas, Matplotlib, Seaborn. Once you import that, then you need to read the data file. So we have this data, sleep, health and lifestyle dataset.csv file. So we will read this data file using pd.readcsv function. Okay. So once you import the data file, then you need to use this readcsv function from pandas library and you need to mention the path of your data set. So whenever you use any function like readcsv, isNull function, always check the documentation of that particular function. For example, if you want to check the readcsv documentation, you can just press shift tab, keep your cursor on readcsv and check the documentation. So this is the documentation of the entire readcsv function. So file path we have already passed. Then we have separator, delimiter, header, names, index column. These are the parameter. So read this parameter and how to use, you can read those documentation. So using this documentation, you can able to understand how to use this readcsv function. Okay. So inside this readcsv, I have given a path of the file sleep, health and lifestyle dataset.csv, which is present in my folder directory. So you can verify that using this command. Like if I just type ls, okay, ls is not recognized as internal and external, means this ls command belongs to Linux machine. So I can simply write dir directory. So inside the current directory, you can see directory of w cloud sleep disorder prediction. This is my project folder. And here you can see this is the data set. So if I can access that using this directory, then I can directly mention that. If you want to check currently you are in which directory, you can just simply type pwd, means present working directory. Okay, for this you don't need to pass the exclamation. Type pwd, which will return the present working directory. So currently I am at sleep disorder prediction directory and inside this directory, you can see this is the CSV file like sleep, health and lifestyle dataset.csv. So let's read this CSV file using pd.read function. So we will store that in a data frame variable and then use df.head. So if I execute this part, you can see the entire data set. Now this df.head will return first 5 record from the data frame. So you can see we have person ID, gender column, age column, occupation column, sleep duration, quality of sleep. Now you need to make sure that when you pass your data to the machine learning model, it should not contain any string variable. But here you can see in gender we have some string value, then occupation will also contain some string value, then BMI and all. So before directly passing data to the machine learning model, we need to process it. So we'll start with basic pre-processing and data visualization to understand the data in a proper manner. So let's start with data pre-processing part 1. So here I will see whether the missing value is present in this data set or not. So if you write df.isNull command, then isNull will count how many missing values present in each column, and sum will give you the total sum of the missing value. So when you execute this command, then you can see we have person ID 0. That indicates there is no missing value inside the person ID column. Then gender column. So again 0, that means no missing value inside the gender column. Then again age, occupation. So in all the columns there are no missing value. But if you see 219, so 219 missing value is present in sleep disorder. Okay. Now let's check how many rows we have. So you can just type df.shape. And for shape, no need to use open and close bracket. You can just type df.shape, shift enter, and this 374 indicate that this particular data frame contains 374 rows and 13 columns. Now out of 374, 219 columns does not have dependent value. Okay, because that will be our third category, none. None means that person does not have any sleep disorder. Okay, so first thing we need to do that only. So inside the data frame sleep disorder column, we need to replace that. So for that, we will use data frame of data frame. Inside the data frame, we will access the sleep disorder column, and on top of that column, we will apply fill NA function. So this fill NA function will replace the missing value with a predefined value. So I want to replace NA value, missing value, with none value. None means no sleep disorder. So blank value will be replaced by none. So technically we will have three categories: none, sleep apnea, and sleep disorder. In place equal to true means we need to change this data frame only. We don't have to create another data frame and store the value. So we are changing the missing value with none value on the same data frame. So that's why we are using in place equal to true, so that we don't have to assign this same data frame to different variable. So let's execute this thing first. Now you will get some warning because we are using some deprecated function. So that's why we got future warning. So if you get future warning and something like that, you can easily ignore that. It is not affected to the code part. So now we have replaced the missing value from sleep disorder column to none. Let's verify that. Again, you can write same command, df.isNull function dot sum. So see, so now sleep disorder does not contain missing value because we have replaced the NA value, none value, missing value with none category. Okay. Now person ID is not required because it's a unique value for all the instance. So person ID will not help a model to identify whether a person has sleep apnea or insomnia. So it is not a useful column. So that's why using common sense we will drop this column. So again df.drop. So this drop function will drop the entire column. Using x is equals to 1 means I want to perform this operation on column level. That's why I'm using x is equals to 1. If I want to perform this operation on row level, you can use x is equals to 0. In place equal to true means again we are changing the same original data frame. So no need to rewrite the data frame to another variable. So we have dropped the person ID column. Then we need to check the unique values in each column. So in this code, first I will use df.columns. So this df.columns will return a column one by one. So let's say we will write one loop, and from this df.columns we will take first column inside the call variable, and that column we will print it, and we will also print the unique values present in that column. Okay. So let's execute this part. Now here we can see unique values in each column. In gender there are 2 unique values. In age there are 31 unique values. Then occupation has 11, means we have 11 types of occupation. Sleep duration 27, quality of sleep 6. So this particular code is giving a unique values in each particular column. But let's say if you want to see the unique value as well. So for that you can use value count function. So I will write simple again for column in df dot columns. So take one column and here print df, add that column inside this and write value counts. Now if I execute this part, you can see, let's add some line breaker as well. Now see, in gender column, there are two missing value, male and female. So for male, there are almost 189 record. For female, 185 record. Then age has n number of column, n number of values. So we will consider age as a continuous variable, gender as a binary variable, male, female. Okay. Then occupation again categorical variable, sleep duration continuous variable, quality of sleep again we can treat it as quality of sleep. So it is 867954. So we can treat this as a integer number. Then physical activity level again integer numbers, stress level. So this is how using value count you can identify the distribution or the structure of your column, like how many values present inside that particular column. Now if you see blood pressure, so blood pressure is measured in two different ways, systolic blood pressure and diastolic blood pressure. So 130/85. So there are two different blood pressure. So we cannot directly use blood pressure column in the model building. We can use, but not in this way. We will separate this blood pressure column into systolic blood pressure and diastolic blood pressure. So we need to perform some feature engineering on this column. Then again we have heart rate, daily steps, and then sleep disorder, none, sleep apnea and insomnia. So this is how using value count you can identify what kind of categories are present in each column. So let's convert the blood pressure column into systolic and diastolic, like converting one single column into two columns. So for that I'm using data frame. Inside the data frame I want to access blood pressure column, and on this particular column I want to apply a lambda function. So lambda's functions in Python are small and anonymous function. So this lambda function will take the input x and then it will split that particular input using slash, and it will extract only first value, because we have, if you see the blood pressure part, this is the blood pressure part. So I will split the 130/86 using this slash operator. So we will get list with two elements, 130,86. Now from that 130,86, if I select 0 index location, that is my systolic blood pressure. And then again I will apply the same lambda function on the same column, but this time the column name will be diastolic blood pressure. And here instead of 0, I will select 1. Okay, so now I will have two columns, systolic blood pressure and diastolic blood pressure. So once we create two columns, like from blood pressure we created systolic column and diastolic column, then we can drop this entire variable. So df.drop this column blood pressure, x is equals to 1 indicate that we are doing column level operation. Okay, in place equals to true, again that means we are changing the same data frame. So let's execute this code, and then again this part, BMI category. So if you see BMI category, so let me go to this part again. Count type, quality of sleep. So in BMI category you can see we have normal, overweight, normal weight, obese. So if you see normal and normal weight, both are same category, but they have been denoted using two different values. So that's why we will merge this normal and normal weight into one single category. So for that I'm using this dot replace function. So data frame BMI category means inside the data frame I want to access this BMI category column, and I want to replace this BMI category column value, column rename with normal weight value. So inside the BMI category, if there is a value called normal weight, replace that value with just normal only. Okay. So now let's execute and override the same BMI category column. So whenever we get normal value, normal weight value, we will just rename that to normal, so that this normal and this normal will be combined together. So this kind of edge case you can able to identify when you write a dot value counts function. Okay, let's execute this part and let's do the df dot head. So now we can see we have BMI category, systolic blood pressure, diastolic blood pressure, sleep apnea will be our dependent variable and it contain none values, means the person does not have sleep apnea. Now checking the unique values from each categorical column. So we have seen this part, like inside the value counts, these are the unique values, but you can also use this logic. So data frame dot occupation dot unique, then BMI category unique, sleep disorder unique. So why I'm using this? Because I know that we have only occupation, BMI category and sleep disorder. Only these three columns contain categorical data. So we need to check how many categories are present inside each column. So that's why on each particular data frame column, I'm applying unique function. So now I execute this particular part. So I can see these are the unique categories present inside the occupation. So somehow I need to convert all this category into numbers. Then BMI category. So in BMI we have three classes: overweight, normal, obese. And in sleep disorder we have none, sleep apnea, insomnia. And in occupation, we have already seen. And there is one more column, gender. But in gender we only have male and female category. Okay. So in next part, so till now we have seen the data preprocessing, how to handle the missing data, how to see unique values and unique categories in each particular column. So now in next part, we will see how to perform EDA and how to extract information from that from EDA part using Matplotlib and Seaborn library.